Hi everyone, today we'll be talking about vectors using the map of Greece. We'll be using vectors as a route for our starting point to our final point. So our problem is, first we'll look up a map of a country, which is Greece, then superimpose an XY grid over the top of an image. 3. Find a city in the lower left-hand side of the grid, quadrant 3. As starting point, make sure the city lies exactly on an intersection of lines. And finally, number 4, explain using vectors how you would go from the starting destination to the final destination. The endpoint of each vector should try to land on a city, or as close as possible, along the way to your final destination. It should have at least 4 vectors before you reach your final destination. For our procedure, we will use vectors into finding a way to get to our destination, which is from Argostoli in the 3rd quadrant to Athens in the 4th quadrant. For review, the upper right-hand corner is the 1st quadrant, the left upper corner is the 2nd quadrant, the left lower side is the 3rd quadrant, and the lower right corner is the 4th quadrant. So, our steps into solving the problem. Our first step is to determine our givens. So the first given is our starting point, which is Argostoli in the 3rd quadrant. Our ending point is Athens in the 4th quadrant. Each vector must end on a city and must have at least 4 vectors before reaching the final destination. Our second step is to set the relationship between givens and the problem. Because the problem is dealing with vectors, let's review what a vector is. A vector is similar to an array. They both look the same, but is measured by magnitude, length of a vector, and direction, way of a vector. The starting point of a vector is called the initial point, being indicated by a point or a dot, and the ending point is called the terminal point, being indicated by an arrow head. There are 3 ways to notate a vector. By the given notation, which is vector AB, or by counting the spaces between the 2 points. For example, point A is -4, -2, and point B is 4 and 2. Spaces between them is 6 up and 6 to the right. To notate them, we would add chevron 6, 6, or simply add parentheses and put both numbers on the top and on the bottom. Our third step is solving the problem. So our first vector would be to Argostoli to Arta. Our second vector would be Arta to Lamia. Our third vector is Lamia to Sparta. And our fourth vector is Sparta to Athens. Vector 1 has its point A is -3, -1. Point B is -2, 3. Our vector 2 is -2, -3, and 2 and 2. Vector 3 is point C, 2 and 2. Point D is 2 and -4. Vector 4 is point D, 2 and -4. And point E, 5 and -1. These are the points that make up the vectors. So, the definition of the spaces of the vectors mean how much space does from one point have to go to another point, such as the first vector. You have to go 1 space to the right and go 4 spaces up to reach the other point. So, the second vector goes 4 to the right and 1 down. The third vector goes 0 to the right or left and 6 down. And the fourth vector goes to 3 spaces to the right and 3 spaces up. So, to determine the total amount of all the vectors, we can create new vectors by adding the current ones, such as AC equals AB plus BC, giving us AC equals 5, 3, AD equals AC plus CD, giving us AD equals 5, -3, and finally CE equals 3, 9. By adding the total of the new vectors, we can determine the total amount of all the vectors. So by adding all the vectors that we found, we got 13, 9. In conclusion to the video, the total amount of all vectors from starting point to the final point is 13,9. Thank you for watching.